Welcome back. In this lesson, we're going to look at what causes the plates to move. So if the tectonic plate theory is suggesting that all of the continents and oceans are actually plates that are moving, in constant moving, bumping into each other, pulling away from each other, grinding past each other, what causes them to move? What is the mechanism that will give them the energy to move around? How do you move a mountain? If you remember Alfred Wegener, who was the first to propose this idea that the plates are moving around and shifting around on the surface of the earth, one reason why he was rejected by almost worldwide by most of the scientists in the early 20th century is because there wasn't a mechanism to explain how in the world something as heavy as a continent could be moving around. And there was no evidence that anyone could see that it was happening because if you don't know how it could happen, you don't even know where to look. So this lesson is talking about the idea of how that you could float around something very, very heavy like a continent on the Earth's surface. It happens really because if the least dense material is floating. So even though you think of something like a mountain as being very heavy, if you have something denser underneath that mountain, then the mountain floats. And so the Earth is thought to be in layers of different material. You have the crust on the outside, you then have the mantle underneath the crust, and then you have a couple layers of core underneath that, and all made out of different materials with different densities, and then the lighter floats on top of the heavier. Now the solid crust of the Earth is floating on a semi-solid or a liquid mantle, and it's the mantle as you have hot and cold spots in the mantle, and you have some convection currents in the mantle that is thought to give the energy of the crusts to move around. Okay, so if you remember convection currents is simply hot rises, cools off, and sinks. So just like the air above a campfire, hot rises, cools off, and then sinks, and then replaces the material in the air, or in the case of a boiling pot of water, the water is replaced by the sinking water, and then it's heated again and it continues to rise. Well, you could have that in the core. If you have hotter and cooler materials inside the core, then, or in the mantle, under the crust, then it would give sufficient energy to move the floating crust on top of it. So if you have the mantle, okay, the mantle can have convection currents too. So the heated material is going to rise up, and then the cooling material is going to sink, and it's going to behave just like the pot of boiling oatmeal. Okay, so if in the case that this is a picture of the break in the crust halfway across the ocean, remember you have these trenches along the inside, and then you have these ridges along the middle of the ocean. Well, the ridges are very thin, and you have new material be planted in these undersea ridges. So that is the youngest material in the crust. It cools then, and as it's cooling, it's lighter. Okay, it's lighter than the rest of the material. So if you have the ocean floor, the lighter material is going to rise up, and so this ridge rises up, and then the denser material sinks, and so you have the edges of the ocean floor sinking. So as it sinks, it's going to sink, actually subduct underneath the continental crust. So the continental crust is actually less dense than the ocean crust. It's made out of different types of rocks. It rises up, the ocean crust sinks, and then as it happens, there's two main reasons why that the ocean floor goes away from the ridge in the middle. And the first is the fact that the ridge is higher, it's less dense, and so it's higher and it's pushing. And then as it subducts, that subducting plate pulls. All right. So if I were to lay my tie across the table and I've got a lot of it dripping over, there's going to be a time where there's enough hanging over the edge that it will pull the rest of it. The tie will simply completely pull off of the table because the heavy part of the tie that's over the table is pulling on the part of the tie that's still sitting, if that makes any sense. You almost have to see it. Okay? All right, so these two terms are called essentially push and pull. All right, so the push is that ocean ridge. Okay, it's called ridge push. That ocean ridge is lighter, it's new material, it's less dense, and so it rises up. And as it's rising up, the other is sinking. It's more dense, and it sinks. And then the weight of that pushes it towards the trench, or pushes it towards the continent. That whole side of the ocean floor is being pushed towards, say, North America and Asia, if you want to think of the Pacific. Okay, so as it's doing that, then the second one is called slab pull, and slab pull is the part that's already subducted under the continent is heavy, and as it's heavy, it pulls, and it's pulling the whole ocean floor underneath the shelves of the two continents. Okay, so that is the mechanism that gives the idea of plate tectonics, or someone that would consider it, because there is enough energy to move the crust around simply by the underground energy of the mantle specifically.